Hello friends, in this video we are going to discuss JEE Advanced 2014 Paper 1 in Physics section. The question number 1, it states that at time t equals to 0, terminal A in the circuit shown in the figure is connected to B by a key and an alternating current I equals I0 cos omega t with I0 equals 1 ampere and omega equals 500 radian per second starts flowing in it with the initial direction shown in the figure. At t equals 7 pi by 6 omega, the key is switched from B to D. Now onwards only A and D are connected. A total charge Q flows from the battery to charge the capacitor fully. If C equals 20 microfarad, R equals 10 ohm and the battery is ideal with the EMF of 50 volt, identify the correct statements. Option A. A magnitude of maximum charge on the capacitor before t equals 7 pi by 6 omega is 1 into 10 raised to the power minus 3 coulomb. Option B. The current in the left part of the circuit just before t equals 7 pi by 6 omega is clockwise. Immediately after A is connected to D, the current in R is 10 ampere and Q equals 2 into 10 raised to the power minus 3 coulomb. Well, here if we draw the variation of current, then it will look like this. Variation of current with time. It will look something like this. Okay, so here this point is pi upon 2 omega. This point, the minimum point, is pi upon omega, and just after this point at some distance, this point is 7 pi by 6 omega. Okay, and this point is 3 pi by 2 omega, and this point here, this point is 2 pi by omega. Okay, now between t equals to 0 to 7 pi by 6 omega, charge will be maximum. Charge will be maximum at t equals pi upon 2 omega. So charge becomes maximum where current is 0 because dq by dt here becomes 0. So therefore at t equals pi by 2 omega, the charge will be maximum, and therefore maximum charge will be equal to integration from 0 to pi by 2 omega I0 cos omega t into dt. So if we solve it, this becomes I0 upon omega sin omega t from 0 to pi by 2 omega. Okay, so this comes out to be Q max comes out to be I0 upon omega, so which is equal to 1 upon 500, which becomes 2 into 10 raised to the power minus 3 coulomb. So maximum charge is 2 into 10 raised to the power minus 3 coulomb. So therefore option A is incorrect here. Well, now at time t equals t equals 7 pi by 6 omega, sense of current here, sense of current is opposite to initial sense. Okay, now since initial sense is here in the question, initial sense is clockwise. Here initial sense which is given in the question is clockwise. Here this is clockwise, so therefore the current will be anti-clockwise here. Therefore sense of I at t equals 7 pi by 6 omega is anti-clockwise. Okay, so now if we solve it further, now Q is here, Q initial, that is Q at 7 pi by 6 omega is integration from 0 to 7 pi by 6 omega I0 cos omega t dt. This becomes I0 upon omega sine omega t from 0 to 7 pi by 6 omega. Okay, so if we solve it further, therefore Q initial, it comes out to be 1 upon 500 into sine 7 pi by 6 omega. So this is minus 1 upon 1000, which is minus 10 raised to the power minus 3 coulomb. Okay, this is the initial charge. Okay, so now if we apply KVL, Kirchhoff's voltage law, immediately after switch is shifted to D. Now applying KVL immediately after switch is shifted to D, then this comes out to be plus 50 plus 10 raised to the power minus 3 upon 20 into 10 raised to the power minus 6 minus 10 into I. This is equal to 0. So from here we get the value of 10I equals 50 plus 50. So from here I equals 10 ampere. Okay, and now the final charge on C. Now final charge on C after shifting to switch is QF, which is equal to C into V, which comes out to be 20 into 10 raised to the power minus 6 into 50, which is 10 raised to the power minus 3 coulomb. Therefore, total charge transferred is Q final minus Q initial, which is equal to 10 raised to the power minus 3 minus 10 raised to the power minus 3 coulomb. So this becomes Q equals 2 into 10 raised to the power minus 3 coulomb. Okay, so here if we look at the options here, first option is incorrect. Magnitude of maximum charge on the capacitor is 2 into 10 raised to the power minus 3 coulomb. The current in the left part of the circuit just before T equals 7 pi by 6 omega is anti-clockwise. Therefore option A and B are incorrect. Now option C is correct. Here if after applying KVL we have found out that I equals 10 ampere. Now Q is also correct one. We have found out that total charge transferred is 2 into 10 raised to the power minus 3 coulomb. Okay, so now let's look at another question. The question says a light source which emits two wavelengths, lambda 1 equals 400 nanometer and lambda 2 equals 600 nanometer, is used in a Young's double slit experiment. If recorded fringe widths for lambda 1 and lambda 2 are beta 1 and beta 2 and the number of fringes for them within a distance y on one side of the central maximum are m1 and m2 respectively, then A beta 2 greater than beta 1, B m1 greater than m2, C from the central maximum third maximum of lambda 2 overlaps with fifth minimum of lambda 1, D the angular separation of fringes for lambda 1 is greater than lambda 2. Well, here since we know that beta equals lambda d upon small d, so because lambda 2 is greater than lambda 1 here, therefore this implies that beta 2 is greater than beta 1. Okay, and also since m equals y upon beta, so therefore this implies that m1 greater than m2 because beta 1 is greater than beta 2. Okay, so now here third maxima of lambda 2 lies at 3 into 600 nanometer into capital D upon small d. So this comes out to be 1800 into capital D upon small d nanometer. And fifth minima of lambda 1 lies at 2 into 5 minus 1 into 400 into capital D upon 2D nanometer. So this comes out to be 1800 into capital D upon D nanometer. So therefore, third maxima of lambda 2, it overlaps with fifth minima of lambda 1. Now angular separation, since angular separation we know about it, that angular separation is beta upon capital D, which is equal to lambda upon small d. Now since lambda 2 is greater than lambda 1, therefore it is more for lambda 2. So therefore, by looking at the options, option A is correct, option B is correct, and here option C is also correct. Option D is incorrect. Okay, so now let's see another question. One end of a taut string of length 3m along the x-axis is fixed at x equals 0. The speed of the waves in the string is 100 meter per second. The other end of the string is vibrating in the y direction so that stationary waves are set up in the string. The possible waveforms of these stationary waves is or are. Okay, so here there should be a node at x equals to 0. We know that there should be a node at x equals to 0 and an antinode at x equals to 3m. Okay, now also we know that v equals omega upon k, which is equal to 100 meter per second. Okay, so now therefore here y equals to 0 at x equals to 0 and y equals to plus minus a at x equals 3 meter. So these two conditions must be satisfied by the possible waveform. Okay, so if we substitute these values, in the options given here, then only A, C and D satisfy the condition. Therefore the correct options are A, C and D. Okay, so now let's see another question. Question says a parallel plate capacitor has a dielectric slab of dielectric constant K between its plates that covers 1/3 of the area of its plates as shown in the figure. The total capacitance of the capacitor is C, while that of the portion with dielectric in between is C1. When the capacitor is charged, the plate area covered by the dielectric gets charged Q1 and rest of the area gets charged Q2. The electric field in the dielectric is E1 and that in the other portion is E2. Choose the correct options ignoring edge effects. Well, here since we know that C equals C1 plus C2 and C1 here is K epsilon naught A upon 3 divided by D and C2 here is epsilon naught into 2A upon 3 divided by D. Okay, so therefore C comes out to be K plus 2 into epsilon naught A upon 3D. So from here C upon C1 is K plus 2 upon K. Okay, so and now also since here E equals V upon D, therefore E1 equals E2. Electric field remains same, where V is the potential difference between the plates. So therefore the correct options here in this case are A and D. These two are the correct options. Okay, so now let's see another question. Let E1R, E2R and E3R be the respective electric fields at a distance R from a point charge Q. An infinitely long wire with constant linear charge density lambda and an infinite plane with uniform surface charge density sigma. If E1R0 equals E2R0 equals E3R0 at a given distance R0, then these are the options. Q equals 4 sigma pi R0 square, R0 equals lambda upon 2 pi sigma, E1 R0 upon 2 equals 2 E2 R0 upon 2 and E2 R0 upon 2 equals 4 E3 R0 upon 2. Well, according to the given conditions here, E1 R equals Q upon 4 pi epsilon naught R square. So this gives us E1 into R0 upon 2 equals 4q upon 4 pi epsilon naught r naught square. Okay, and E2 r equals lambda upon 2 pi epsilon naught r, which gives us E2 r naught upon 2 equals 2 lambda upon 2 pi epsilon naught r naught. Okay, and E3 r equals sigma upon 2 epsilon naught. So therefore E3 r naught upon 2 equals sigma upon 2 epsilon naught. Now it is given here that since it is given that E1 r naught equals E2 r naught equals E3 r naught. Okay, so therefore this implies us that q upon 4 pi epsilon naught r square equals r naught square equals lambda upon 2 pi epsilon naught r naught equals sigma upon 2 epsilon naught. So taking these two conditions here, taking this condition here and this condition here, taking these two together, we will get q equals 2 pi r square sigma. Q is equal to 2 pi r square into sigma. And if we take this here and this here, then we will get, after taking these two equations, we will get lambda upon pi r equals sigma, or r equals lambda upon sigma pi. Okay, so if we substitute these values in our equation of electric field, then we will get here E1 r naught upon 2 equals 4, E1 into r naught equals 2, E2 into r naught upon 2. This is the first, and also we will get E2 into r naught upon 2 means E2 r naught upon 2 equals 2 E3 r naught equals 2 E3 r naught upon 2. So the only correct option here is option C. Okay. Now let's see another question. A student is performing an experiment using a resonance column and a tuning fork of frequency 244 per second. He is told that the air in the tube has been replaced by another gas. Assume that the column remains filled with the gas. If the minimum height at which resonance occurs is 0.350 plus minus 0.005 meter, the gas in the tube is, here we are the given approximations: neon, nitrogen, oxygen, or argon. Okay, so now since we know that L equals 1 upon 4 nu under root gamma RT upon M. M here is in the kilogram. Okay, M here is in the kilogram. So therefore, after converting it into gram, we get L equals 1 upon 4 nu under root gamma RT upon M into 10 raised to the power minus 3, where now M is in grams. Okay, so if we just calculate here the value, or after simplifying it, we can get that L equals 1 upon 4 nu under root 100 gamma RT into under root 10 upon M. Okay, now if we substitute the values of gamma here, value of gamma is 1.67. Gamma is 1.67 for monoatomic gases. And gamma equals 1.4 for linear or diatomic gases. So if we substitute the value of gamma, then in case of neon, we will get the value of L as L equals 0.459, and in case of nitrogen, we will get the value as 0.363, and in case of oxygen, we will get the value as 0.340, and in case of argon, we will get the value as 0.348. Well, since the value of L should lie between, now value of L should lie between 0.345 to 0.355 meter. Okay, so since the value of L here, since it is given that the error is 0.005 meter, therefore the value of L should lie between 0.345 to 0.355 meter. Therefore the only option here that satisfies the condition, these are in meters actually, therefore the only option here that satisfies the condition is option D. Okay, so now let's see another question. Question says, heater of an electric kettle is made up of a wire of length L and diameter D. It takes 4 minutes to raise the temperature of 0.5 kilogram water by 40 Kelvin. This heater is replaced by a new heater having 2 wires of the same material, each of length L and diameter 2D. The way these wires are connected is given in the options. How much time in minutes will it take to raise the temperature of the same amount of water by 40 Kelvin? Well, we know that time here is H upon P. Okay, so which comes out to be H into R upon V square. Now, this gives us that time is directly proportional to resistance, that is R. And we know that R equals rho L upon A. Now, since since D dash equals 2D, D dash equals to 2D, this gives us R dash equals rho L upon 4A. Okay, so now when wires are in series, R1 equals R dash plus R dash. This gives us 2R dash. Okay, so 2R dash, which is R upon 2. Well, R dash equals R upon 4. So this is equal to R upon 2. So which gives us T dash equals T upon 2 equals 2 minutes, because T is directly proportional to the resistance. Now, when wires are in parallel, then R2 equals R dash upon 2, okay, which is equal to R upon 8. So therefore this gives us T dash equals T upon 8, which is 0.5 minutes. So the correct options here are option B and option D. Okay, so let's see another question. Question says, in the figure, a ladder of mass m is shown leaning against a wall. It is in static equilibrium, making an angle theta with the horizontal flow. The coefficient of friction between the wall and the ladder is mu1, and that between the floor and the ladder is mu2. The normal reaction of the wall on the ladder is n1 and that of the floor is n2. If the ladder is about to slip, then these are the 4 options that are given to us. Well, if we draw the free body diagram here, just drawing the free body diagram, then the free body diagram will look something like this. Okay, this will be n2, this is theta, this is n1 here, this is n1, and the friction which is mu1 n1, and this is mu2 n2. Okay, and here somewhat in the middle, mg, which is the force due to weight. Okay, so this is point B and this is point A. Now, mu2 can never be 0 for maximum equilibrium, since mu2 can never be 0 for maximum equilibrium. Okay? Now, when mu1 equals to 0, we have here n1 equals mu2 n2. The horizontal forces will be balanced because mu2 n2 and n2 equals m2g, balancing vertical forces. Then mu2 will be equal to m2g. This is the first, this is the second equation. Okay, and by balancing torque here, torque about B will be equal to 0, which gives us mg into L upon 2 cos theta equals n1 L sin theta. Okay, so this gives us here n1 equals mg cot theta upon 2. So, which is equal to n1 tan theta equals mg upon 2. n1 tan theta equals mg upon 2. Now, when mu1 is not equal to 0, then we have mu1 n1 plus n2 equals mg, and mu2 m2 equals n1. Okay, balancing horizontal and vertical forces here. This is the balancing of vertical force, this is the balancing of horizontal force. So this gives us here n2 equals mg upon 1 plus mu1 into mu2. Okay, so the correct option here in this case is option C and option D. Okay, here correct option here is option C and option D. Okay, so now let's see another question. Question says a transparent thin film of uniform thickness and refractive index n1 equals 1.4 is coated on the convex spherical surface of radius r at one end of a long solid glass cylinder of refractive index n2 equals 1.5 as shown in the figure. Rays of light parallel to the axis of the cylinder traversing through the film from air to glass get focused at distance f1 from the film, while rays of light traversing from glass to air get focused at distance f2 from the film. Then, well, here as thickness of film is uniform, we can write a comment over here that as thickness of film is uniform, if it is uniform, the effective power of the film is 0. Okay, effective power is 0. Now, therefore, we can find the answer just by considering this glass-air interface. Okay, therefore, answer can be found by considering glass-air interface. Okay, so now in case 1 here, in case 1, mu2 upon v minus mu1 upon u equals mu2 minus mu1 upon r. We know this. So this gives us 1.5 upon f1, since u is 0, rays are parallel, u is 0. Therefore this will be 0 equals 1.5 minus 1 upon r. After solving it, this gives us f1 equals 3r. Okay, now in case 2, mu2 upon v minus mu1 upon u equals mu2 minus mu1 upon r. Now this gives us 1 upon f2 minus again 0, u is 0, equals means u is infinite here, so this gives us 1 minus 1.5 upon r minus r. So from here we can get f2 equals to r. So the correct options here are option A and option C. Option A and option C. Okay, so now let's see another question. Question says question says that two ideal batteries of EMF V1 and V2 and three resistances R1, R2 and R3 are connected as shown in the figure. The current in resistance R2 would be 0 if Now if we apply KVL here, or first let's draw the circuit here. Drawing the circuit, okay, here this is here is R2 and so this is the circuit given to us. Here this is R2, this is R1 and this is R3, and let's say that current is in this direction, which is I. Okay, so current will be like this. This is V1, this here is V2. Okay, so now if we apply KVL in this circuit, in this A, B, C, D, E, F, A, okay, A, B, C, D, E, F, A. If we apply in this circuit, the outer circuit, using KVL, applying KVL in A, B, C, D, E, F, A, we get minus I R1 plus V2 minus I R3 plus V1 equals 0. So this gives us I equals V1 plus V2 upon R1 plus R3. Okay, so value of I is V1 plus V2 upon R1 plus R3. Now if we apply in second case, this is the first case. Now in second case, if we apply KVL in ABCDA, if we apply in this circuit, applying KVL, applying KVL in ABCDA, we get, now here assuming that current in R2 is 0. We have already assumed that current in R2 is 0. Then 0 plus V1 minus IR1 equals 0. So from here we will get I equals V1 upon R1. So this implies that V1 upon R1 equals V1 plus V2 upon R1 plus R3. Okay, so if we write the value of current in the equation that we have got from case 1, then we will get V1 upon R1 equals V1 plus V2 upon R1 plus R3, which simplifies in this form. Okay, which gets simplified in this form. So therefore from here we can get V1 upon R1 equals V2 upon R3. So this condition must be satisfied here. This is the condition which must be satisfied here in this case. Now if we put this, if we use V1 equals V2, means if we use these conditions in this equation, then only A, B and D satisfies that equation. Therefore, the correct options are A, B and D. C does not satisfy that equation. Okay. So now let's see another question. So from here onwards, the questions are one integer value correct type. Okay. So the question says, airplanes A and B are flying with constant velocity in the same vertical plane at angles 30 degree and 60 degree with respect to the horizontal respectively as shown in the figure. The speed of A is 100 root 3 meter per second at time t equals to 0 second, and observer in A finds B at a distance of 500 meter. This observer sees B moving with a constant velocity perpendicular to the line of motion of A. If at t equals to t naught, A just escapes being hit by B, t naught in seconds is, well, here if we draw the FBD, then it will look something like this. V1, this is 30 degrees, and here this will be V2, which is 60 degree, or here this will be like this. If we write here V1 from this point of reference, then this will be something like this. This is 30 degree, okay, and the perpendicular direction is this, which is here V2 sine 30, and this is V2 cos 30 degrees. Okay. Well, from this diagram we can easily see that V1 equals V2 cos 30 degrees. So from here 100 root 3 equals V2 into root 3 upon 2, which gives us V2 equals 200 meter per second. Okay, so therefore T naught is D upon vertical velocity, this velocity V2 sine 30 equals D upon V2 sine 30 degrees. So this gives us 500 upon 200 into 1 upon 2, which comes out to be 5 seconds. So the correct answer here is 5. So the answer here is 5. Okay, so now let's see another question. Question says, during Searle's experiment, 0 of the vernier scale lies between 3.2 into 10 raised to the power minus 2 meter and 3.25 into 10 raised to the power minus 2 meter of the main scale. The 20th division of the vernier scale exactly coincides with one of the main scale divisions. When an additional load of 2 kg is applied to the wire, the 0 of the vernier scale still lies between 3.2 into 10 raised to the power minus 2 meter and 3.25 into 10 raised to the power minus 2 meter of the main scale. But now the 45th division of vernier scale coincides with one of the main scale divisions. The length of the thin metallic wire is 2 meter and its cross-sectional area is 8 into 10 raised to the power minus 7 meter squared. The least count of the vernier scale is 1 into 10 raised to the power minus 5 meter. The maximum percentage error in the Young's modulus of the wire is, we know that Young's modulus Y equals F upon A upon delta L upon L. And now delta L here is 25 into 10 raised to the power minus 50 meter. So delta L here is 25 into 10 raised to the power minus 50 meter. So now from here Y equals F upon A into L upon delta L. So if we write here, if we just solve it further, we will get delta Y upon Y into 100 equals 10 raised to the power minus 5 upon 25 into 10 raised to the power minus 5 into 100 equals 4%. So the answer here is 4%. So the correct answer is 4. Here this is 10 raised to the power minus 5, not 10 raised to the power minus 50. Okay, so the correct answer here is 4%. Okay, so now let's see another question. Question says, a uniform circular disc of mass 1.5 kg and radius 0.5 meter is initially at rest on a horizontal frictionless surface. Three forces of equal magnitude F equals 0.5 Newton are applied simultaneously along the three sides of an equilateral triangle XYZ with its vertices on the perimeter of the disk. The 1 second after applying the forces, the angular speed of the disk in radian per second is, well, here if we draw the free body diagram, then this will look at this point this will look at as x. Suppose this is at x point, this is at x point, therefore FBD will look something like this. This will be F cos 30 degree, okay, and this will be the circle's center, and this will be the vertical component of F. Okay, so at this point this will something look like this. So therefore torque is 3 into, since here radius is 0.5 meter, and since torque will act at all three directions here, at all 3 points, therefore torque will be 3 into F sine 30 degree into R. This is R and this will be F sine 30. Since at point Y also, if suppose this is point Y, then this will be F sine 30, and if and since this point, if this point is Z, then here torque will be in somewhat will tend to rotate it in this direction, so that will also be F sine 30. So the torque will be 3 times of F sine 30 into R. So this comes out to be torque equals 3 into 0.5 into 0.5 into 0.5, which is equal to 3 upon 8. Okay, so torque is 3 upon 8. Now I, that is moment of inertia, is mr square upon 2 in this case, which is equal to 1.5 into 0.5 into 0.5 upon 2, which comes out to be around 15 upon 10 into 1 upon 8, which is equal to 3 upon 16. Now therefore torque is I alpha. So from here alpha equals torque upon I, which comes out to be 2. Now omega will be equal to omega naught plus alpha t. Okay, now since omega naught equals 0, therefore omega equals alpha t equals 2 into 1 equals 2. So the correct answer here in this case is 2. Okay, so now let's see another question. Question says, two parallel wires in the plane of the paper are distance x naught apart. A point charge is moving with speed u between the wires in the same plane at a distance x1 from one of the wires. When the wires carry current of magnitude I in the same direction, the radius of curvature of the path of the point charge is r1. In contrast, if the currents I in the two wires have directions opposite to each other, the radius of curvature of the path is r2. If x0 upon x equals 3, the value of r1 upon r2 is, well, we know that b1 equals mu naught I upon 2 pi x1 minus mu naught I upon 2 pi into x naught minus x1. So this comes out to be mu naught into I upon 2 pi 1 upon x1 minus 1 upon x naught minus x1. Okay, so from here if we solve it further, then b1 will be mu naught I upon 2 pi x naught minus x1 minus x1 upon x1 into x naught minus x1. So this comes out to be mu naught upon I upon 2 pi, mu naught into I upon 2 pi into x naught minus 2x1 upon x1 into x naught minus x1. Okay, so and now B2, now B2 here is mu naught into I upon 2 pi 1 upon x1 plus 1 upon x naught minus x1. So this comes out to be mu naught into I upon 2 pi into x naught upon x1 x naught minus x1. Okay, so and now since we know that B is directly proportional to R, therefore R1 upon R2 equals B2 upon B1. So B is inversely proportional to R. It is not directly proportional to R. So since B is inversely proportional to R, therefore R1 upon R2 equals B2 upon B1. So this is equal to x naught upon x naught minus 2x1. So if we divide numerator and denominator by x1, then this comes out to be x naught upon x1 upon x naught upon x1 minus 2. So from here R1 upon R2 equals 3 upon 3 minus 2, which is equal to 3. So the correct answer here is 3. Correct answer is 3. Okay, so now let's see another question. To find the distance D over which a signal can be seen clearly in foggy conditions, a railway engineer uses dimensional analysis and assumes that the distance depends on the mass density ρ of the fog, intensity S of the light from the signal, and its frequency f. The engineer finds that that D is proportional to S raised to the power 1 upon n. The value of n is, okay, so now since here dB equals rho raised to the power a, here dB is rho raised to the power a, s raised to the power b, and f raised to the power c. So therefore m naught L raised to the power 1 t raised to the power 0 equals m raised to the power a L raised to the power minus 3a into m raised to the power b t raised to the power minus 3b into t raised to the power minus c. So this comes out to be m raised to the power a plus b into L raised to the power minus 3a into t raised to the power minus 3b minus c. Okay, so from here a plus b equals 0 and minus 3a equals 1. So from here, if we solve it further, we'll get a equals minus 1 upon 3 and b equals 1 upon 3. Okay, so therefore from there n equals 3. Since s is b, therefore we needed to calculate the value of 1 upon b. Since b equals 1 upon n, therefore n equals 3. So the correct answer here in this case is 3. Okay, so now let's see another question. The question says a galvanometer gives full scale deflection with 0.006 ampere current by connecting it to a 4990 ohm resistance. It can be converted into a voltmeter of range 0.3 volt. If connected to a 2n upon 249 ohm resistance, it becomes an ammeter of range 0. It becomes an ammeter of range 0 to 1.5 ampere. The value of n is, well, a galvanometer gives full scale deflection with 0.006 ampere current by connecting it to a 4990 ohm resistance. It can be converted into a voltmeter of range 0 to 30 volt. If connected to a 2n upon 249 ohm resistance, it becomes an ammeter of range 0 to 1.5 ampere. Okay, so now well, here Ig equals 0.006 ampere. and R equals 4990 ohm. So if we draw the circuit, part circuit, it will look something like this. This is RG and this is R. Now V equals 30. Since the range is 0 to 30 volts, now V equals 30. Therefore V equals IG into RG plus R. So substituting here, V equals 0.006 into RG plus 4990. So this comes out to be here, that 30 into 10 raised to the power 3 upon 6 equals Rg plus 4990. So from here, if we solve it further, Rg will come out to be 10 ohm. Okay. Now if we draw the circuit, now the second part here is, in case of second part, circuit looks something like this. This is Ig, this is I, this is I minus Ig, this is Rg, and this is here 2n upon 249 ohm. Okay. Well, solving further, we will get 0.006 into 10 equals 1.5 minus 0.006 into 2n upon 249. Okay, 2n upon 249. So which gives us 0.06 upon 1.5 equals 2n upon 249. So from here, 2n equals 0.06 into 249 upon 1.494, which comes out to be 10. Okay, so this gives us n equals 5. So the correct option here in this case is 5. Correct answer is 5. Okay, so now let's see another question. Question says, consider an elliptically shaped rail PQ in the vertical plane with OP equals 3 meter and OQ equals 4 meter. A block of mass 1 kilogram is pulled along the rail from P to Q with a force of 18 Newton, which is always parallel to line PQ. Assuming no frictional losses, the kinetic energy of the block when it reaches Q is N into 10 joules. The value of N is, now G equals 10 meter per second square. Well, here Wg, work done due to gravity, is minus mgh. We know this. So therefore this is equal to minus 1 into 10 into 4, which is minus 40 joules. Now, and here work done by, therefore work done here in this case, the other is work done due to forces F into D, which is equal to 18 into 5, which is plus 90 joule. Okay, so now kinetic energy is plus 90 minus 40, which is equal to 50. So from here 10n equals 50, which gives us n equals 5. So the correct answer here in this case is 5. Okay, now let's see another question. Question says, a rocket is moving in a gravity-free space with a constant acceleration of 2 meter per second square along plus x direction. The length of a chamber inside the rocket is 4 meter. A ball is thrown from the left end of the chamber in plus x direction with a speed of 0.3 meter per second relative to the rocket. At the same time, another ball is thrown in minus x direction with a speed of 0.2 meter per second from its right end relative to the rocket. The time in seconds when the two balls hit each other is... Well, here we know by applying Newton's equations of motion, the second equation of motion, here S1 is 0.2 t plus here S1 is 0.2 T plus half into 2 into T square, and S2 is 0.3 T minus half into 2 into T square. So therefore S1 plus S2 is 4. Here it is given to us the length of a chamber inside the rocket is 4 meter. Therefore S1 plus S2 is 4. And if we sum these two, from these two we can get 0.5 T equals 4, which gives us T equals 8. Okay. Now if we assume closed chamber, the collision will be very close to the left end. Hence the time taken by ball B to reach left end will be given by here. If we draw the diagram like this, therefore if acceleration is here in this direction, A equals 2 meter per second square, and second acceleration is again in this direction, equals 2 meter per second square. Then this is ball B, this is ball A. Ball A will move back after some distance, and U is 0.3 meter per second. Okay. And here in case of ball B, it is 0.2 meter per second. Okay. Now the collision will be very close to the left end. Therefore collision will be very close to the left end. This is the second case which we are discussing right now. Hence time taken by ball B to reach left end will be given by, therefore time taken by ball B to reach left end will be given by 4 equals, since the length of the chamber is 4 meter, therefore 4 equals 0.2 T plus half into 2 into T square. So in this way time comes out to be 2 seconds. Therefore the answers for this question is either 2 or 8. Okay. In this case the chamber is closed. If we consider the chamber is closed, then the answer will be 2. Okay. So now let's see another question. The question says a horizontal circular platform of radius 0.5 meter and mass 0.45 kilogram is free to rotate about its axis. Two massless spring toy guns, each carrying a steel ball of mass 0.05 kilogram, are attached to the platform at a distance 0.25 meter from the center on its either sides along its diameter. Each gun simultaneously fires the balls horizontally and perpendicular to the diameter in opposite directions. After leaving the platform, the balls have a horizontal speed of 9 meters per second with respect to the ground. The rotational speed of the platform in radian per second after the balls leave the platform is, here we know that 2 mvr equals I omega, since the balls are 2, therefore 2 mvr equals I omega, so which comes out to be 2 into 0.05 into 9 into 0.25 equals 0.45 into 0.5 squared upon 2 into omega. So from here omega is 2 into 0.05 into 9 into 0.25 into 2 upon 0.45 into 0.5 into 0.5. So after solving this comes out to be 4. So the correct answer here is 4. Okay. Now let's discuss the last question of paper 1 of physics section. A thermodynamic system is taken from an initial state I with internal energy Ui equals 100 joule to the final state F along two different paths IAF and IBF, as schematically shown in the figure. The work done by the system along the paths AB, IB and BF are WAF equals 200 joule, WIB equals 50 joule and WBF equals 100 joule respectively. The heat supplied to the system along the path IAF, IB and BF are QIAF, QIB and QBF respectively. If the internal energy of the system in the state B is UB equals 200 joule and QIAF equals 500 joule, the ratio QBF upon QIB is, well, here since this I to A is isochoric process here, therefore WIA is 0 since delta V is 0 here, and WAF is given to be 200 joule. UI here, UI is 100 joule and UB is 200 joule. Okay, now WIB here, which is given to us as WIB equals 50 joule, WBF equals 100 joule, QIAF here, QIAF is equal to 500 joule. Okay, QIAF which is given to be as 500 joule. Now therefore WIAF equals WIA plus WA2F. Since WIA is 0, WA2F is 200 joule, therefore this comes out to be 200 joule. And delta U equals UF minus UI equals 300 joule. So from here UF is 400 joule. Okay, delta U is here which is Q minus W, which comes out to be 300 joule. Okay, so from here UF is 400 joule, which comes out to be 400 joule. Now QIB, here QIB is UIB plus WIB, okay, from first law. So this comes out to be 200 minus 100 plus 50, which is 150. Okay, which is 150. QIB is 150 and QBF is UBF plus WBF, which is equal to 400 minus 200 plus 100, which is 300. So therefore QBF upon QIB equals 300 upon 150, which is equal to 2. So the correct answer for this question is 2. Okay, so that's all of our discussion of paper 1 physics section of JEE Advanced 2014.